Okay, this video is going to be going over how to measure your tool lengths and inputting your tool diameters. There's basically 4 different ways here at the Tech that we can measure our lengths with the Haas machines. On one of the Haas and one of the VF tools here, we have the probing system. There'll be another video that will go over that. For the older VF1, we actually have this tool measuring tree calibrated for that machine. And basically what you do with that is you measure the length of your tool off the reading. You got this stands for 2 inches, 3 inches, 4 inches, 5, 6, 7. So we're at 8 inches, and whatever your micrometer would read, 0.112. So you would input for this tool, if you're using this on the older Haas machine, 8.112. And then if you were in the VF tool, you want to set your part 0 off the bottom of the quill. Not the keys, but the bottom of the quill. That is one way you can do it. The most common way is here at the school to what you're going to be doing is you're going to be measuring all your tools off a common surface. And what I mean by a common surface is a surface that's not going to change. We're going to use the top of the table. Another one that people will use is the back side of the hard jaw. Not the front side of the hard jaw, because that does change. It floats back and forth, and it can float up and down a few thousandths. But the back side will not change. Another surface that some people will use is the bottom of the vise. That's not a real desirable surface to use, just because you may have a part in there while you're machining. You might have to measure a tool. Maybe you forgot a tool. Maybe a tool breaks, and you have to remeasure a tool in the middle of the process, and maybe you can't get to this surface. So one of the 2 best ones is the top of the table or the hard jaw. We're going to use the top of the table. Okay. Now there's a couple of different ways that you can do this to find out where that top of that tool is in relationship to the top of the table. You can use a piece of paper. You come down and you type that, you just till you feel the friction on that. I don't really like using that, and I wish you will not use that, just because it's a good way to break tools. Maybe you come down too fast. Maybe after you do your offsets, you hit the wrong direction on your Z and it comes down on top of the table. So we want you to use a 1, 2, 3 block. Does not matter if you use the 1, the 2, or the 3. I generally just use the 3-inch side. So I'm going to come down until I can hit. I want to keep, anytime you come down in the Z axis, you do not want your block underneath your part. So okay, so right there, I know I'm too low. So I'm going to go into my hand jog. I'm going to go into a 1,000 increment. And I'm just going to go up. And now that I know I'm too high, I'm just going to come down 1 click at a time. Okay, right there I'm feeling friction. So I know I'm right at exactly 3 inches off the top of the table. Now, do not leave that in there when you come to your offsets, because if you forget that it's in there, you go the wrong direction, you're going to break something. So just pull it out. It's not going to go anywhere. So I'm going to go into my offset page until my tool offsets are highlighted. Okay? Now, it's always going to show up. The highlighted one under the tool numbers is what's in the spindle is what you're working with. Okay? But you got to make sure that you highlight it is the spindle that's in the spindle. Okay? So we're under tool offsets, under H and the length, and we're working with the geometry. Okay? So once I'm with tool number 1, that's in the spindle. I got the tool length and the geometry highlighted. Now I'm going to hit tool offset measure. Okay? So now that I have that value is how far this tool is from machine home, but it's 3 inches off the table. So we want to account for the 3 inches that we use on the 1, 2, 3 block. And the only thing I'm going to do there is minus 3 point, because we want the offset to go further down. and we're going to hit the right enter button. Now remember, if you hit -3 and you hit F1, you input that -3 inches. That's not what you want. If you happen to do that, no big deal. Tool offset measure again, and we're going to go -3 point. Okay. If you're not sure which way to go with the negative, with your 1, 2, 3 block out of there, if you notice the operator and the machine numbers here are the exact same, what's up there. If I bring this farther down, this becomes more of a negative number. So I know I want it to go more negative. For some reason, if you go the wrong way and you add 3 inches and you don't catch it right away, what's going to happen is when you come to machine your part, your tool is going to be 3 inches above your part. So you won't crash, but you will, it'll just cut 3 inches above your part. Okay, so now that's my length for this end mill. Okay, but also it's an end mill, so the machine needs to know how big it is. So I'm going to raise it up. And I want to measure how big that tool is. Best way to do it is actually take it out. You get a micrometer. And you're actually going to measure very gently. You want to make sure you get the biggest part of that diameter. So this end mill actually measures 0.612. So we're going to go under tool number 1 for the diameter geometry and type in 0.612 F1. We're going to input that value into the machine. Now, this being a roughing end mill, I want to leave more material on, and this is where you're going to want to do that. You can either do that in the geometry or in the wear page. I like doing it in the wear page because I can actually physically go back to this page and see that I did that. So let's say if I want to leave 20 thousandths on, material on for either a finished cut or to make sure I cut this part to size. So when the machine looks up in your program, when it goes and tries to find the diameter, it's going to add these two numbers together. So when the machine's cutting with this end mill, it thinks it's a 0.632 end mill. And that'll leave material on for, like I said, for either finished cuts or to cut the size. So our tool for that, tool offsets for that tool are set. So we're just going to put this back in the machine. Okay, we'll just do another one. We're going to do, let's do the center drill. So we got to call up the center drill. That's tool 3 in this case. Close our doors. Okay. Hand jog down to the top of our part. Once again, anytime you're coming down in the Z-axis, you don't want to leave that in there. You want to keep it out. So I'm going to come down until I'm too low. Go to the 1,000ths. Okay, there, now I'm too high, and just come down a little bit at a time. Okay, right there, and I can actually slide that in. Okay, so I know, once again, I'm 3 inches above my table. Okay, so now you notice that tool number 3 is highlighted in the offset page. It says the spindle is by tool number 3. So I want to come over here. Under the tool offset, the length. Okay, and I'm going to hit tool offset measure. Okay, once again, I got to count for my 3 inches on the 3-inch block. So I'm going to go -3 point. So there, that's how far that tool is from machine home down to the top of the table. Okay, I don't have to do anything with diameters because you never use cutter comp with any kind of a drill, center drill, tap. If you want to put it in here just so you have a reference what it is, feel free to. So you want to call it 0.125 if that means that, you know, it's an 1/8 inch center drill or 1/8 inch drill. But it does not matter for the function of the machine what the diameter is on the drill. So you would go through and measure all the tools this way. We'll do one more real quick. Okay, this time just to show the difference, we'll use a 2-inch side. Same thing. Okay. Bring it up. Okay, right there I feel the friction. So I know I'm 2 inches above the part. Back to our offset page. I want to be under the length for tool number 4, tool offset measure. But now this time we used the 2-inch side of the block, so now I'm going to subtract 2 inches and hit right enter, and that does the math for you. So you would go through and measure all the tools in your program. If you're going to run 2-3 parts at one time, you can measure all your tools. It doesn't have to be the tools that you only use in your program. You just want to measure any tools that you're going to be using for the day off the top of the part. So now we have to find out where the top of our part is in relationship to the top of our table. Okay? And there's a couple different ways you can do it. You could actually get a height gauge and measure from here to here. That's all you're looking for, is the difference from here to here. Or we can use our spindle. And using the values off the machine, we're basically going to use this as a tape measure. So I'm going to hand jog it up above the part. Okay. So now I have to find where this point of this drill is in relationship to the top of our part. So just like we did, off the top of the table, we're going to find out where this part is 3 inches above. Okay, so right there, I can feel the friction. So now we're exactly 3 inches above the part. So you're going to find your calculator again. You're going to go under machine, the machine value. In this case, it says a negative 2.303. But we want to account for that 3 inches of that block. So we're going to take that, 2.303, add the 3 inches for the 3 inch on the 1, 2, 3 block. So that value is 5.303. In this case, if you notice they're both negatives, we're not really worried about the negative numbers. We're just trying to find the difference between where the machine is and where that tool length offset is for that part. So now I have the 5.303, and I want to go to my offset page, and you want to make sure you're using the offset length for the tool that's in the spindle. This could be highlighted anywhere, okay? But you want to be looking, we got tool 4 in the spindle, and we want to be looking at the length for that tool. So I have 5.303, and now I'm just do a minus 11.053, because that's the tool offset value for that tool. And I come up with a number of 5.75. Okay? Now if it happens to be negative, you're just going to use a positive value because it's above, your value is above your common surface. If for some reason you were using a common surface like here and your part 0 was below, that would be a negative value. But for the most part, it's always going to be a positive value. And what you're going to do with this number is you're going to go to your work offset page. And I'm going to highlight my z-axis if I'm using G54. And I'm actually just going to input that value, 5.75. Okay? So that's exactly the distance from here to here. So if you ever want to double check yourself, what you can do is take a straight edge, another parallel, and hold it over the top of your part and get yourself a ruler, and you should be pretty close to 5 3/4 of an inch. If this value says 10 inches something, 10.75, you know you did something wrong and recheck your numbers. For some reason, if you would input a negative 5.75, what's going to happen is your machine's just going to zero out because the machine knows it cannot drill that deep. So if you do put the wrong polarity in there, that's not the end of the world. Once again, the machine won't crash. It won't let you run. You'll find that out right away when you do your graph. So 5.75 is actual value from here to the top of our part. If our top of our part was a finished surface and we weren't doing anything, you'd be done, you'd be ready to go. In this case, we want to make sure we clean this up. We want to cut across top of our part, and then more likely we use a face mill, and in your program you want to machine that in at Z0. So if you did in your program machine Z0 with your face mill, it would just basically skim across that and it wouldn't cut anything off. So we want to take off 10, 15, 20 thousandths off of this surface. Best place to do that is under your work offset. And what I'm going to do, if I want to take 20 thousandths off there, I'm going to go minus 0.02. And once again, let the machine do the math for you. So you hit right enter. So after hitting right enter, our value now reads 5.730. So basically, our Z0 is 20 thousandths below this surface. If you would run your program again, for some reason, maybe it didn't clean up and you have to take some more off, just come back. If I want to take another 5 thousandths off, 0.005, right enter. By doing it here in your work offset, all your tools will follow that Z0. If you do it in your program, all your tool lengths are going to be off because you're cheating the Z surface in your program and not in your work offset. So that's basically how you set all your tool lengths and get in the relationship to the top of your part to the top of your common surface.